Hi and welcome. In this video, we'll see some further examples of frequency distribution table. The first example is regarding the academic status of all students in Math 099 Section 5 in spring semester 2021. Based on this frequency distribution table, we have 16 undergrad students and 4 academy students. The relative frequency 80% is undergrad, 20% is academy. Now, based on this frequency distribution table, how many values this variable can take? Is it important to order the values in a certain way? As we can see, the variable academic status takes two values, undergrad or academy. And it's not important to order the values because this is a qualitative variable which is nominal. Second question is, what is the population? And list two population parameters. Obviously here, the population is all students in Math 099 Section 5, and two population parameters can be the 80%, which is the portion of undergrad students in the class, and 20%, which is the portion of academy students in the class. Do we have even or uniform distribution? No, because the number of academy students and the number of undergrad students are way different. In fact, we have 4 times more undergrad students than academy students. Therefore, the distribution of the variable academic status in this class is not uniform. How many percent of students are either undergrad or academy? Of course, 100%, because as we add the two, 80 plus 20, it's 100%. That means 100% of students are either academy or undergrad. Second example is concerning the class level of all students in Statistics 1 class. As you can see here, we have 2 freshmen, 14 sophomore, 6 junior, and 3 seniors, in total 25. The percent of each class is provided in this column of relative frequency, as well as we have cumulative frequency here in the last. The first question is, how many values this variable takes? Is it important to order the values in a certain way? First of all, we know that the variable class level takes 4 different values, freshman, sophomore, junior, and senior. Yes, it's important to order the values from freshman, sophomore, junior, and senior, and this order should be respected because the class level is an ordinal variable. What is population? List 3 population parameters. When would we have a sample statistics? First of all, the population is all students in statistics 1 class, all 25 of them, this population. 3 population parameters can be the number of freshmen, the percentage of sophomore, 56%, or the number of junior students or the number of senior students. All of them are population parameters. When we would have a sample statistics, we know that sample statistics is the output of mathematical calculations on the data collected from a sample. Therefore, if we have a sample of students from the class and we calculate, for example, the number of freshmen or the percentage of sophomore and so on, we get sample statistics. Do we have even distribution? Obviously not, because the number of freshmen is very, very different from the number of sophomore and junior and senior. Therefore, we do not have uniform distribution. How many are junior or lower? That means how many are junior, sophomore, or freshman. We know that 6 plus 14 is 20, plus 2 is 22. In terms of percentage, 88% are junior or in lower class level. How many percent are sophomore or junior? That means how many percent are in the second class or in the third class. If we add the two, 56 plus 24 you see 80%. 80% of students in the class are either sophomore or junior. How many percent are fresh or senior? That is how many percent are in the first or last class. We have 12% here, 8% there, and 12 we have 20% are either senior or freshman. In the next example, we have the age of 20 randomly selected newly admitted patients to a hospital on the 1st of February 2021. And we have the frequency distribution table of the age of these 20 newly admitted patients. We have 6 infants, 3 children, 1 teens, 2 adults, and 8 older adults. The relative frequency is being given in this column and cumulative frequency is presented here. First of all, how many values this variable can take? If we consider the variable age itself, it can take all integers from 0 to over 120 or 130. But in this example, we have classified the variable age into 1, 2, 3, 4, 5 categories. Therefore, our categorized age here takes 5 values. Order is important, of course, because the lower age comes first, then the higher age is following. What is population? Population is, of course, all newly admitted patients at this hospital on the 1st of February, from which, of course, we have chosen 20 randomly. Sample is, of course, 20 randomly selected newly admitted patients. 2 population parameters. If we would have the age of all newly admitted patients on that first day of February, and we calculated the absolute frequency or the relative frequency or the cumulative frequency, all of those were population parameters. Now, since we are having sample data, all these numbers here, in other words, all absolute frequencies, all relative frequencies, all cumulative frequencies, are sample statistics. Do we have even distribution? No, because we have way more infants and older adults compared to other 3 age categories. What can you conclude after skimming the table? What we can conclude is immediately we see that most of the patients, at least in our sample, are either infants or older adults. How many percent are infant or older adults? We can add the percentage of older adults, which is 40, and infants, which is 30. In total, we have 70% are either older adults or infants. How many percent are teens or adults? Teens or adults, here we have one teens and 2 adults. 5 plus 10 is 15%. The next example is concerning the monthly income of 30 families who are living in a village. The frequency distribution table of the monthly income of these 30 families in this village is given here. We have 10,000 to 20,000, 12 families, 20 to 38, 30 to 46, more than 44. Percentages are given in the relative frequency column, cumulative frequencies are given here. The first question is how many values this variable can take. Obviously, the monthly income can take infinitely many values, but as far as this categorized version is concerned, we have classified this variable into 4 categories. Population, all families living in that village. Sample is the collection of these 30 families that we have selected as sample. 2 population parameter, for instance, if we have the monthly income of all families in the village and we find the number of families with income between 10 and 20,000 and relative frequency of the families with income between 20 and 30,000, those are population parameters. Sample statistics, we have a lot of them already here. All numbers here, all numbers here, all numbers here. They're examples of sample statistics. Do we have even distribution? No, we don't have even distribution. Rather, we have decreasing kind of distribution against the amount of income. That means as the amount of income increases, the frequency decreases. What can you conclude after skimming the table? The first conclusion that one can make is that the number of families with lower income is higher compared to those with higher income. How many percent are earning 30,000 or less? That's 30,000 or less here, the first class and the second class. That is 27 plus 40%, which is 67%. How many percent are earning more than 30,000? That is class 3 and class 4, 20% plus 13%, which is 33%. And finally, how many percent are earning in the interval 20 to 40,000? So that's starting from 20,000 and 40,000. That is second class and third class. If you add the relative frequencies here, 27 plus 20 is 47%.